we have now addition of harmonic motion. Now find the sum of two harmonic motions. So we have your x of 1, so that will be the function of time, so that will be equal to 10 cosine of your angular velocity times time. Then my x of 2, so that will be the function of time, is equal to 15 times the cosine times the angular velocity times time plus 2. Okay, so we will be introducing three methods here. Now, method 1 is by method 1. Okay. So that is by using the trigonometric relations. So since the circular frequency is the same for both your x of 1 function of time and x of 2 function of time, so we can express your x, no? So I can express my x, so that will be my resultant, so that is equal to my a amplitude cosine, no? Angular velocity plus times time, so that will be plus the alpha, which is equal to my x of 1 function of time plus my x of 2 the function of time, no? And also I can rewrite here, so this one is equal to, so I can equal here the value of x of 1, so that will be 10, no? 10 cosine times the angular velocity times time, then plus your x of 2, so that will be 15, no? Cosine times the angular velocity time plus 2. Okay. Now using the trigonometric identities, so from your trigonometry, now for my trigonometric identities, so I have these trigonometric identities, which is that will be cosine, no? That will be cosine of your alpha plus your beta. So that is equal to cosine of alpha, cosine of beta, minus sine of alpha, sine of beta. Okay, so I can use these trigonometric identities and substitute it to the equation there. So I can rewrite my equation from both sides, no? As we have that will be a, no? So that will be cosine. So I'm gonna close parenthesis this one. So that will be cosine of your angular velocity times time, then cosine of your alpha, so minus sine of your angular velocity times times, and then sine of your alpha. Okay, so this is the part on my left side of my equation. Then when I equate this one, so that the value of this one will have your 10, no? So that will be cosine, okay, cosine of angular velocity times time, then plus, that will be 15. This will become close parenthesis, since we can express this cosine angular velocity times time plus 2, we can express by using these trigonometric identities. So this will become my cosine times my angular velocity times time, and then times my cosine of 2. Okay, so that gives the value of this one angle. Then I'm gonna minus this one to sine of my angular velocity times time, and then sine of value of 2. So close parenthesis on that one. Okay. Then I can rewrite this one, or I can expand this one as my, so expanding my equations here, I can expand this one or distribute yung values na ito. So I can say that this will become my a cosine angular velocity time, then this is cosine alpha minus your amplitude, that will be sine angular velocity times time, and sine of your alpha, and this is equal to my 10, that will be cosine times angular velocity times time. Then distribute the value 15 to the law of the equation method, that we have your 15 cosine angular velocity times time, then cosine of 2 minus, we have distributed, we have 15 sine angular velocity times time, and then sine of 2. Okay, so that is being expanded now. Now taking and equating the coefficients for both sides for cosine of angular velocity times time and sine of angular velocity times time. So taking the coefficients of that one. So from here we have coefficients of cosine angular velocity time, so that will be A, amplitude times my cosine of your alpha. Okay, and equating on the other side, so that will be 10, no? So coefficient of cosine angular velocity times, so coefficient, that will be 10. Okay, then plus again coefficient angular velocity times time, so I have 15, no? 15 times of cosine of 2. Then for my sine times sine of angular velocity times time coefficient, on this side we have that will be coefficient is sine sine of your alpha is equal to this will be 15, no? So taking, if this is negative, it will be both cancel positive naman. So I have 15 dito, so that will be 15 sine of your 2, no? So that will be my coefficient. And then I can rewrite this one, or let's say I can square both sides, add these equations, so I can square and add this one. So adding my A cosine of alpha plus my sine of alpha. Okay, so I square this one, then this is equal to the value of my 10 plus 15 cosine of 2. Okay, so this will become squared also, plus that will be 15 sine of 2. Okay, so this will be also squared. Okay, then you can say this can be squared, so it will be equal to A squared cosine squared alpha plus my sine that will be, sorry, this is we have a coefficient, that will be sine of A. Okay, we forgot here, coefficient of this one does have a value of amplitude A. Okay, so that will be this one will become this is A and this is A sine of alpha, so this is squared, so I have my alpha here. So let me adjust this one, to adjust this one just a little bit, so this will become my plus A sine alpha. Okay, so this will be squared also, and this will hold my whole equation here as 15 cosine of 2, so close parenthesis squared, and this also keep holding the same equation from this one, so that will be squared. Okay, now we have a trigonometric identities again. So trigonometric identities, I'm gonna write here so that you will be well aware of these identities. Where it is equal to cosine squared theta plus my sine squared theta, so it is equal to 1. Okay, so for this one, you will notice here that this cosine squared alpha plus a sine squared alpha, so we can factor this one, and we can rewrite or express this one by these trigonometric identities. So I can factor this one, so this one will become a squared, and this will become a cosine squared alpha plus my sine squared alpha. Okay. And this is, again, I keep holding these equations the same. That will be 10 plus 15 cosine of 2, so that will be squared, plus 15 sine of 2, okay, squared. So I keep holding on this the same equation. Now since this one is cosine squared theta, sine squared theta is equal to 1, so that will be my a squared, that will be equal to 1. Now again, so this is keep holding the same equation previously. We rewriting on just one here, squared plus close parenthesis 15 sine of 2, so this will be squared also. Now I can rewrite my amplitude here as that will be equal to the square root, no? So the square root ng values nito, so that will be 10 plus 15 cosine of 2, so this is expressed as a squared, 10 plus I have my 15 again, 15 sine of 2, okay, that will be is squared. Okay. Now this is in terms of radian, so the value of your 2, no, the angle here is in terms of radian. Now I'm going to rewrite the equation here. So firstly I'm going to convert the 2 degrees in terms of degrees also. This one is radian, the angle for this one is radian. Okay, so rewriting that one, so I have here this is okay, that will be 10, no? That will be 15, and this is cosine, so this is 2 multiplied, so change my bracket here, so I'm gonna make this one a bracket, not on. So this will become 2 times 180 times your 5. So to convert it radians, this is radian, so this is pi radian. Okay, so I'm gonna square this one, and sorry, not square, but I'm gonna close this one, parenthesis, then another close parenthesis and square. Okay, then I'm gonna add here, no, so that will be plus close parenthesis, so this will be 15 times sine, okay, then close parenthesis on this one, that will be 2 times 180, no, over pi radians. Okay, then close this one, so I'm going to square this one. Forgot to add more square here, parenthesis here. Okay, so we have now, we can directly now, so my amplitude here, so my amplitude is equal to that will be 14.147. for my amplitude. Then for the angle, so that will be tangent. For the angle, I have here tangent of my alpha. Okay, so that will be equal to that will be 15, no, sine. So I'm gonna directly convert my angle of radian to degrees. So that will be close parenthesis, that will be 2 times 180 over my phi radian, to cancel the radian here and to make it a degrees. Okay, so this is all over. That will be 10, no? So that will be 10 plus 15, okay, then times the cosine, so close parenthesis on this one and close parenthesis on this one, so that will be 2 times again 180 over my phi radian. So close parenthesis and then close parenthesis. So let's properly use this over sine. Then using my calculator, so finally I have the angle of which is equal to 74.5. Okay, so this becomes 74.5 degrees. Okay, so let's have a quick recap on the solution. Now, we're using here method 1 using a trigonometric relations. So again, so we can express the function of my vectors as a cosine angular velocity times then you have your alpha for the angle, and this is equal to my the sum of my harmonic motion. We have 10 cosine angular velocity times time, and then that is 15 cosine angular velocity times time and plus 2. Okay, then from my trigonometric identities, so this is the cosine of alpha plus your beta, so this is equal to cosine alpha then cosine of beta minus sine of alpha and sine of beta. Then express this one in terms of my trigonometric identities, so I can expand the whole equation by this one. Okay, then again, so we can distribute the value of your A, and also on the other side I can distribute the value of 15 on the expansion side of my equation. Then again, so using now taking and equating the coefficients of both sides for the cosine of angular velocity and the sine of angular velocity times time. So coefficient ng cosine angular velocity times time, so that will be cosine of A, cosine of alpha on my left side equation, and then on the right side that will be 10, and also that will be also 15, no? So 15 cosine of my 2. Then for my sine angular velocity times time, so we have the coefficient that is A sine of alpha is equal to 15, so coefficient niya ito, then sine of 2. Then I can add this left side and also on the other side and square both sides of the equation. Then we can finally arrive on this expanded equation. Now again, now we have the trigonometric identities, which is cosine squared theta plus sine squared theta is equal to 1. So we can factor the a squared from the cosine squared and sine squared. So this one is equal to 1 since we have the trigonometric identities. Then we can equate this one on taking hold the same equation previously. Then again, so transferring my a squared here, we got the square root of this equation. Then again, so square root, then computing here. So firstly we need to convert the 2, so the 2, the value of 2 that is in terms of radians, we need to convert that one. So I'm gonna multiply here 180 divided by my pi radian, and also the same also that 1 2 here, so squaring that one, then square root. Finally I have the answer of 14.147. And then again, for my tangent, for the angle of the alpha, so the same also we have, we call this the same also we're using here, no, equations, so almost the same. So that will be tangent, no, so that will be 15 sine of 2 times, where your 2 is my angle here. Again, we're going to convert from 100 to degrees, so I'm going to multiply the angle by 180 divided by radian. So then we have 10 plus your 15 cosine, no? Then convert in again. So finally, we have the angle of your alpha, that is 74.5.